So the wedge AMA, the actual mechanical advantage, is still the same formula. Well, for wedges, the force of the resistance is actually how much it's being squeezed, how much the wedge is being squeezed inwards, like this, and the however much it's being squeezed is also the same amount that it's pushing out, because unless you're like crumbling the wedge. So we're not going to ever be able to really measure that, like if we have a wedge or something like that. If we use it in a machine, we won't be able to measure the actual mechanical advantage of that. At least, I don't think we will be able to. Maybe we will. I don't know. However, the resistance is how much it's being squeezed, which is the same thing as how much it's pushing outwards. And then in the end, the force of the effort is what you're applying to like force the wedge through whatever you're doing. So here, you just take the 700 and divide it. You don't have to do 1400. It's the same force on both sides, just because it's cutting through the same thing. So you don't have to take both of them. It's just 700 divided by 250. Okay, what is that? That's 2.8. So what does that mean? Well, you're applying 250 pounds of force, maybe like with a hammer or something, and what's actually happening is the piece of wood, like if you had a piece of wood here, it's getting cut open and split this way with a 700-pound force. So, and normally it would take 700 pounds for this piece of wood to be split open if you're just trying to pull those pieces apart. But with the wedge, it'll feel like you're using 250 pounds. Yeah, that's pretty sweet. So this is a simple machine that amplifies your input. Anytime you're amplifying your input, it feels like you're doing something easier than what it actually takes to do that object or task. What's next? I tell you what's next is screws. So what's a screw? It's two pieces pretty much. It's an inclined plane that's kind of wrapped around a cylinder. What does that mean? It's like if you look at a screw really closely, you have a screw. These are kind of like little triangles. It's like an inclined plane, man. Come on, man. So you got this inclined plane going all the way around your screw, and then you got like a wheel and axle on the edge of the screw. It's kind of like let me draw a picture. So you got like the top of the screw there, and then you got like a wrench out here, and this wrench is like the wheel. This is like the axle. Yeah. So you'll be applying force out here in a rotational manner, and then the inclined plane will be driving the screw, in this case, downwards into the iPad. No, the iPad, or up into if you're unscrewing it. So the purpose of screws is supposed to change the rotary motion into linear motion. That's in this case, you turn this circle into like an up and down motion out of the screen. It uses a threaded fastener, or used as a threaded fastener. So it's like instead of like a nail, which would just be a wedge, it's a screw. It kind of holds it in better. You can fasten it to stuff. Has a very, very large AMA, mechanical advantage. The problem is there's so much friction that goes on in here that you lose a lot when you actually calculate AMA. Well, let's move on. Let's see. Here's some stuff about screw identification just before we get on to the other things. So the effort arm for a screw is just the center of the screw all the way out to the edge of the top of the screw. Unless you're using a wrench, then it's from the center all the way out to the end of the wrench that you're using. So there's that. The pitch is the distance between two threads. Like if you took trig, the pitch would be the distance between the two peaks of like a trig function. The crests, that would be the pitch. The diameter of the screw is just the diameter of the threads, not the diameter of the top of the screw, so careful with that. And when you see a type of screw, you have the diameter first, that's the first number, you'll probably have to reference this. Threads per pitch, per inch, that can give you the pitch, actually. So threads per inch, how many of these little things are there in 1 inch? And I actually can't remember what NC, maybe not coarse, I don't know. So this would be fine threads, like really small ones, or coarse threads, I think would be really big ones, like that. I don't know, I'd have to look that up. The easy way to get the pitch is just by knowing the threads per inch. This is something you're going to need to know for your exercises. If there are 13 threads per inch, then the pitch is 1/13 of an inch. It's easy. So like if you had a really huge screw and there were like 170 threads per foot, I don't know, then your pitch would be like 100 and I forgot what I said, 137. I don't know, 1/137th of a foot. So it's really easy to get the pitch if you know how many threads per whatever unit of measurement you're using. So that's how you do that. So how far will a screw with 13 threads per inch move linearly? So move up or down. That's the question. In one full rotation. Well, it turns out if you turn it one time around, it goes by one pitch. That's the whole idea. If you turn it, if you turn it one time around, it's going to travel that distance downwards. So this will be 1/13 of an inch. How many rotations would it need to travel 1 inch? Well, 13. It's just that simple. All right, let's move on. The IMA for a screw. Oh, look at this. 1/4. What does that mean? This is threads per inch. So it's 20 threads per inch, meaning it has a pitch of 1/20th. 1/20th of an inch. Sorry, lost my train of thought there. And then the 1/4. Well, let's see. What was that? That was the diameter. So it's a quarter. I'm going to say a quarter of an inch diameter there. So for screws, the distance of the effort is 1 rotation of the effort arm. So it's the same thing as circumference. So this stuff you're going to have to use in your calculations. And then the distance of the resistance is how much you travel up or down. And that's it. That's all you got to. Huh. Okay. Same thing as pitch. So, IMA, remember, it's just distances, so it's going to be the distance or the circumference of the turn with the rotation arm or effort arm, and then also just the distance between the two threads, which is the pitch. So what is the pitch of the screw above? 8-inch long wrench. So we have to find the circumference of an 8-inch long wrench. Well, if the wrench were out here and we rotated all the way around, the wrench would be the diameter. Or sorry, the radius. So we could actually use 2 pi r. And so we'll have 2 pi times 8 inches. And then divide it by the pitch. Well, this said that we had, 20 threads per inch. So the pitch will be 1/20th of an inch. Or 1/20th inches. And that comes out to like 1005.31. It has a really large mechanical advantage. However, there's so much friction in here that it feels completely different. But there you go. That's for that. And I think that's it. This video went long. All right. Goodbye.